In this video, we'll write the Lewis structure for MnO4. This is the permanganate ion. The first thing we need to do with Lewis structures, we need to figure out the valence electrons for the entire ion here. So Mn, this manganese here, that's a transition metal. It's a little more difficult to figure out the number of valence electrons for those. If we look at the electron configuration for Mn, we'll see that it ends in 3d5,4s2. So we'll end up with 7 valence electrons for the manganese atom. Oxygen, that always has 6, group 16, and then we have 4 oxygens here, plus this negative sign here. It's negative because there's an extra electron, so we're going to add one more. 28 plus 8, 32 total valence electrons for the MnO4 Lewis structure. So Mn, that's the least electronegative atom, and then we'll put the oxygens around the outside. So we have 32 valence electrons. Let's put pairs of electrons between these atoms here to form chemical bonds. So we'll use up 8 valence electrons doing that. Next, we'll go around each oxygen, put valence electrons around to complete the octets for those. So this looks like a pretty good Lewis structure. We have an octet on all of the oxygens, and this central manganese, it has an octet as well. The problem is if we calculate the formal charge, the manganese, that has a 3, positive 3, and then each one of these oxygens around here has a negative 1 for the formal charge. What we would rather have is things close to 0 as possible, or in this case, close to this charge up here, this 1 minus. To do that, we're going to have to use some double bonds. So we could move this pair of electrons here to the center. That would still have an octet for oxygen. This would have an expanded octet, but that's okay. And now the formal charge would be 0 for this oxygen, and this would be plus 2. So we can move another pair here, and then another pair here. And by doing that, we maintain the octets for each of the oxygens. The manganese, I can have an expanded octet, and we have this minus 1 here. That equals the charge on the ion. So this would be a good Lewis structure, probably the most likely Lewis structure for MnO4-. We should put brackets on the outside though, and then we put a negative sign out here to show that negative charge. And this is the most likely Lewis structure for the MnO4 ion. Note that there are resonance structures. I could have the single bond here, or I could have the single bond here, and this would be a double, or here, or here. And the actual structure would be an average of those resonance structures. And it would look something like this right here, where we'd have this kind of averaging of all these bonds, and this would be the structure that we'd see in the laboratory. This is Dr. B with the Lewis structure for MnO4-. Thanks for watching.